All right. Hi, everyone. These are notes for solving polynomial equations in factored form, which is something that we've actually already dealt with, but we didn't really give it a name yet. So our essential question is, how can we solve polynomial equations? We're going to use the zero product property. We're going to use GCF, the greatest common factor, which you saw on your last big ideas assignment. And then we're going to use a zero product property and apply it to the various situations. So let's just make sure we're all on the same page with some vocab. So factored form is a polynomial that is written as a product of polynomials. We have seen this most commonly written as a product of two binomials. For example, x plus 2 times x minus 6. We've seen these, and we've used distribution to expand items like this. All right, and now the zero product property. That just means if the product, remember products is times, so if you're multiplying two numbers and you get 0, then at least one of the numbers has to be 0. That means if you're multiplying two numbers, A times B, and you're saying, okay, two numbers that are being multiplied together equals 0, that means either A has to be 0 or B has to be 0. Because when you multiply by 0, you get 0. If you multiply anything by 0, you get 0. And now roots is another new vocab word. And no, I'm not talking about growing things. We're not talking about plants. This is just a solution of an equation. So for example, if we have an equation, x plus 6 equals 0, a solution is whatever value x can be to make this statement true. You might say, well, if x is negative 6, then that would be negative 6 plus 6 equals 0, which is true. So we say that x equals negative 6 is a solution. And we also say that x equals negative 6 is a root. It's just a new vocab word for us. And repeated roots is two or more roots of an equation that are repeated. In other words, sometimes you'll have the same solution more than once, and we'll see examples like that. But this is, you will have a solution more than once. We have two vocab words left. Standard form, we've been working with this. This is a polynomial in one variable with exponents of the terms decreasing from left to right. That means you put your highest exponents on the right, and then you decrease as you go towards you put your highest exponents on the left, and you decrease as you go right. So for example, 3x to the fourth power plus 2x squared plus 6. That's a polynomial in standard form. And now the greatest common factor. You may see this just written as GCF. Greatest common factor is the largest factor of two numbers or terms. So if I put two numbers out here, let's say 24 and 20, and I ask you to find the greatest common factor between these, that means the largest number that divides evenly into both of these numbers. And one way you can do this, if you're not quite sure, it's not very clear at first, you can make a list. So let's, for example, 1. You can divide both these numbers by 1, and you get a whole number. 24 divided by 1 is 24. 20 divided by 1 is 20. So 1 works. But is it the largest factor? Probably not. Well, how about 2? You can divide both of these numbers by 2 and get a whole number. What about 3? No, 20 divided by 3 is not a whole number, so 3 is not a factor. Well, what about 4? Yeah, 24 divided by 4 is 6, and 20 divided by 4 is 5. Is that the largest one? Yes, it is. So we say the greatest common factor between 24 and 20 is 4. We're going to use this concept today to talk about factoring polynomials. So we're going to use this concept and apply it to polynomials, which is what we've been learning about. So I'll keep going. Factored form versus standard form of polynomials. So in factored form, this is something where we have two different factors. For example, x plus 6 times x plus 2. And you know, we've been working with lately taking something that looks like this and making it so that it looks like something written in standard form. So we're going to, we've worked on expanding it. For example, we can FOIL it. So we take the first term times the first term. So we get x times x, which is x squared. And then we can take x times 2, which is 2x, right? And then we take 6 times x, which is 6x. You see how these two terms are like terms, and we can combine them. So this will actually just become a positive 8x because 6x plus 2x is 8x. And then lastly, we take our outside term, so we take 6 times 2, which is 12. So factored form is typically two binomials in parentheses. And standard form is just you actually multiply and you expand it. Going forward, we know how to get from this form. We know how to get from factored form to standard form. The next couple of weeks, we'll work on getting from standard form to factored form. So we're going to work on going backwards, but not today. Not today. That's for the future. So that's it for this page. Lots of vocab. Go ahead and flip the page over. And we'll actually talk about solving polynomial equations. So we're going to solve each equation. And to do this, we are going to use the zero property, which states if a times b is equal to 0, that means a equals 0 or b equals 0. That means one of those two terms has to equal 0. Now, class, we're going to work on solving each equation. We're going to use this property. So do you see here in this first example, 3x times x minus 6 is equal to 0. I want to find out what x can be to get this to equal to 0. And do you see how we really have two different parts of this? We have this 3x, and we have this x minus 6, so this is like your part A. And then this x minus 6 is like your part B. So it's like we have two different sets. We have this 3x is one set, and this x minus 6 is another set. So that means to get this whole thing to equal 0, either the 3x has to equal 0, or this x minus 6 has to equal 0. And now, class, let's just start with the one on the left. This 3x is equal to 0. What does x have to be, or how do we get x alone? Well, we can divide both sides by 3. These 3's cancel, and we just get x is equal to 0 divided by 3, which is just 0. So that means x can be 0. Well, let's try it. Let's plug in x equals 0 and see if we really do get 0. So if x was 0, then we'll take 3 times 0 times 0 minus 6. Well, 3 times 0 is 0, and 0 minus 6 is negative 6, and 0 times negative 6 is 0. So we do get 0. So that holds true. X can equal 0. If x is 0, then that is a solution to this equation. Now let's go to the right and take a look at this next part. This x minus 6 equals 0. Well, how do we get x by itself? We can add 6 to both sides, and these 6's will cancel out, and we get x equals 0 plus 6, which is just 6. And if we plug in a 6 for x, we will also get 0. And now, y'all, I want to show you something else on Desmos here. So let's graph both of these. Or let's just graph, let's graph 3x times x minus 6, so this one. And I'll go in projector mode so you can see it. Where does this graph cross the x-axis? It's right here and right over here at 0 and at 6, which are our solutions. And another word for that are roots. So another word for root is x-intercept, which is where your graph crosses the x-axis. So you can always check your work using Desmos here. All right, and now, how about this next example? X minus 5 times x plus 4 equals 0. Well, that means either x minus 5 has to equal 0 or x plus 4 has to equal 0. All right, let's just solve this x minus 5 equals 0. To get x by itself, we need to add 5 to both sides. So this is x equals 5. So if x equals 5, that's a solution. It's a root. So x can equal 5, or let's see, to solve the one on the right, we should subtract 4 from both sides. And we get x is equal to 0 minus 4, which is just a negative 4. So this is our solution, x equals 5 or x equals negative 4. So we have two solutions, two different things that x can be to get this to equal 0. All right, now let's keep going. Let's keep solving some polynomial equations. Let's solve each equation. So using the 0 property, this means that 4x plus 5 has to equal 0, or 4x minus 5 equals 0. So let's do the one on the left first. So to get this 4x by itself, we need to first put this 5 on the other side. So we can subtract both sides by 5. And we get 4x is equal to negative 5. And now to get x by itself, we divide both sides by 4. So we get x is equal to negative 5/4. And that's one of our solutions. Now we need to find the other one. So for this other one, this 4x minus 5 equals 0, first we need to add 5 to both sides. So on the left hand, we're just left with the 4x, and on the right, we're left with the 5. And then to get x by itself, we divide by 4. So we just get x is equal to 5/4. And those are our two solutions for this first example. So if I plug both these numbers in for x, we will get 0. Oh, how about this next one is c plus 6 squared equals 0. Well, we know that this is really just c plus 6 times c plus 6 because exponents are just repeated multiplication. And now we have two different pieces here, two different parts, so we can set each of those equal to 0, and that will be a solution. So we have c plus 6 is equal to 0, or c plus 6 again is equal to 0. That means for both of these, c equals negative 6, and this one we have c equals negative 6. So hey, we had two solutions, but they're the same thing. So y'all, this is called a repeated root. That's one of your vocab words on the first page, on the front page. So this is a repeated root. And now this last one. Maybe you'll be able to see it without writing it out, but I'll write it out. So this has 3 different pieces. That means we can set a plus 5 equal to 0, and that will be a solution. Or a minus 2 equal to 0, and that's a solution. Or yeah, I will write that down there. Okay. Or a minus 7 equals 0. So now let's solve each of these. This first one, a can equal -5. For the second guy, a minus 2 equals 0. A can equal 2. Or a can equal a positive 7. And these are our 3 roots, or our 3 solutions to this equation. All right, now objective 2. And this is what we'll focus on going forward, is a lot of factoring. So let's find the greatest common monomial factor. So right here it says factor out the greatest common monomial factor from 12x cubed plus 3x squared. All right, y'all. Let's just start with 12 and 3. What's the greatest common factor of 12 and 3? That would be 4. So we know. No, it's not. It's 3, isn't it? 4 doesn't go into 3 evenly, but 3 goes into 3 evenly. Ooh, okay, so our greatest common factor between 12 and 3 is 4. So we're going to deal with the 4 for sure. But y'all, see these x's? This x cubed and x squared? I'm going to write this out so that we can see exactly how many x's we have. So for this 12x cubed, this is really 12 times x times x times x, because we have 3 x's. That's what that exponent of 3 means. It means we have 3 x's being multiplied together. And this 3x squared is really just 3 times x times x. So we only have 2 x's. Okay, so the greatest common factor between 12 and 3 was 4. And now we're going to deal with these variables. So we're going to take a look at how many we can take from both of these so that we take the same amount from each term. So you see we have 3 x's here and 2 x's here. That means the max number of x's that we can take from each term is 2, because this term here only has 2 x terms. So this means I'm going to take an x squared out of both terms. Oh, why did I write a 4? Sorry, we're factoring out a 3, aren't we? Okay. Okay, so we're going to factor out a 3x squared, which really means we're going to divide both of these terms by 3x squared, which is really just 3 times x times x. So we're going to divide both of these terms by 3 times x times x. So if I factor out a 3x squared, or I divide this first term, this 12x cubed, by 3x squared, let's just look at these numbers first. Well, if I factor out a 3, and I take 12 divided by 3, what's left? What is that? That's 4. That means we have a factor of 4 left. And then, see, we have 3 x's up here and only 2 down here, which means that 2 of these will cancel, and we're just left with, we only have 1 x left. So this is a 4x right here. So that means if we factor out a 3x squared from 12x cubed, we are left with a 4 and an x. And then we're going to add our factored second term. So 3 times x times x, and we're factoring out 3 times x times x. Oh wait, that's the same thing on the numerator and the denominator. So what is this equal to if we have the same thing in the numerator as we do in the denominator? This is just equal to 1. So this is really just 1. So this is what we have. We have 3x squared times 4x plus 1. And that's a factored version of 12x cubed plus 3x squared. And y'all, if you want to check your work, keep in mind that what we're doing is just the opposite of distributing. So if I want to check my work, I can just distribute. So maybe I can just do this in a different color. You don't have to write this down if you don't want to. So if I distribute and I take 3x squared times 4x. Well, that's 3 times 4 is 12. And then x squared times x is x cubed. So I'm trying to get back where I started. That's the goal. That's what we want. That's how we know we did it right. And then distribute the 3x squared times the 1. Well, 3x squared times 1 is just 3x squared. So is this what we started with? 12x cubed plus 3x squared? Yes, that means we're right. That's how we know we're right. Okay. And I believe I have this one graphed as well. Okay, yes. So you can also check your work by graphing. So if I graph 12x cubed plus 3x squared, we get this guy. This is what it looks like. Y'all, if I graph this factored form, our goal is to not change the graph. Like, we're not supposed to be changing the graph. We're just factoring something out. We're not changing any values. We're not really changing it. We're not creating a whole separate new equation. We're just rearranging some terms. So that would be easier to solve for x. So if I highlight this one, do you see how it didn't really show up? Can you see how the red line is actually underneath of this black line now? That means they're the same line. That means we did it right. That's good. Alrighty. And now objective 2, part 2, solving equations by factoring. All right, we've got 3 problems left here. So we're looking for the greatest common factor. Monomial. So take a look at our constants first, our 4 and our 12. What's the greatest common factor between 4 and 12? Lots of 4. And then how many x's can I factor out? Y'all, we can only factor out the number of x's that is in the term with the least amount of x's. So you see how this 4x squared, that says 2 x's, but this 12x only has 1 x? That means we can only factor an x out of both terms. So if I factor out a 4x from this 4x squared, what are we left with? In other words, what's 4 times x divided by 4 times x? Well, these 4's cancel and these x's cancel. We're just left with an x. Plus, all right, well, what's 12 times x divided by 4 times x? Well, 12 divided by 4, that's a 3. What's x divided by x? Oh, that's just 1. Those cancel out. So we are just left with x plus 3, and we're setting this equal to 0. And now we can use our 0 property to solve for x. So this means either 4x is equal to 0 or x plus 3 is equal to 0. Which means if we solve for x and we divide both of these sides by 4, we get x is equal to 0 divided by 4, which is 0. And then over here, x plus 3 equals 0. Well, to get x by itself, we need to subtract 3 from both sides. To get x is equal to negative 3. So then our solutions are 0 and negative 3. All right. Now this one, oh, this is not equal to 0. So what we're going to do is, well, we're going to set it equal to 0. Set equal to 0, which just means I'm going to move this 10a squared to the other side. So I'm going to add 10a squared to both sides and get 0 is equal to 10a squared plus 8a. All right, now let's factor this 10a squared plus this 8a. So what's the greatest common factor between 10 and 8? Well, that's 2. And then how many a's can we factor out? We have 2 here and only 1 here. So since this one only has 1, we can only factor out 1a. So we can factor out a 2a. So if I factor out a 2 from this 10, we're left with a 5, because 5 times 2 is 10. If I factor out an a out of this a squared, we're left with 1a plus 8a. So if I factor out a 2 from this 8, we're left with a 4, because 4 times 2 is 8. And if I factor out an a from, well, this This is only 1a, so that means we're just left with 1, so that means we're done here. All right, so now we have 2 terms. So we can use our 0 property. So this means that 2a has to equal 0, or 5a plus 4 has to equal 0. So on the left, 2a equals 0. This means that a is 0. And then 5a plus 4, I'll write it out. We're going to subtract 4 from both sides. So this is going to be, sorry. This is going to be 5a is equal to negative 4. Then we divide both sides by 5, so we get a is equal to negative 4. Oh, sorry. Oh, I can move it over. Wow, that's so cool. Negative 4/5. So that means a can be 0 or a can be negative 4/5. All right. So I wish you could ask me questions. I'm sure some of you have some, but feel free, or please, please ask each other questions after this video and make sure that everybody is on the same page and can do these. So make sure you work together. Check in on your neighbors here. Make sure that we're all doing okay. All right. Objective 3, modeling. All right. So we can model the arch of an entrance to a train tunnel by using the equation y equals negative 5/16 times x plus 8 times x minus 8, where x and y are measured in feet. The x-axis represents the ground. Find the width of the entrance at ground level. Y'all, let's use our good friend the Desmos for this. All right, I'll go to Desmos. I already have this plotted for you, so it's right here. Whew, this is large. So this is our arch. And remember, x and y are measured in feet. That means our arch goes 20 feet into the air. This is large. And remember that the x-axis is the ground. So that means we are here at negative 8, and then it goes over all the way to 8. So the question is, find the width of the entrance at the ground level. So that's, maybe I can write on this. Okay, so on the ground level, that's the x-axis. So we're really just looking for the distance from here to here. From x equals negative 8 to x equals 8. You might already say, well, I know that's 16. Because this distance from negative 8 to 0 is 8. And then from this distance from 0 to 8, well, that's just 8 too. So the distance, or the width of the entrance at ground level, is 16 feet. Could you have figured that out without Desmos? Sure, you could have just found the roots to be negative 8 and 8. Just found the distance between those 2 points. Or you can graph it and see this more visually. So let's see. That's it for the notes, y'all. So the rest of the day today, you can work on the learning check and the big ideas for 2.4. And if you have any questions, feel free to email me. I'll check my email throughout the weekend. The learning check will be due at the end of class on Monday, and big ideas will be due at the end of the day on Monday. So come to class on Monday with questions. I'll help answer all your questions. And that's it for this video. So have a great day, everyone. And hey, have a good weekend too.